I'm going to talk primarily about law and mathematics, but I will have a little bit to say about economics as we proceed. So we all know that Husserl was the first to use the expression formal ontology. And he thought that formal ontology is a twin of formal logic. He also talked about formal axiology, which is relevant later. And he saw formal as being the higher level account of what exists. Formal ontology gives you a higher level account of what exists, as contrasted with regional ontology, or what we now call domain ontologies, which use the categories of formal ontology, but they specify them to be more specific. And so formal ontology uses categories and relations like part-whole and so forth, which apply everywhere. And material ontologies then use domain-specific universals and universal connections. But it's important that you can't start to build a material ontology without a foundation in formal ontology. And the reason was expressed already by Bonaventure, who was drawing on Aristotle. So if we grasp the meanings of terms by comprehending a definition of what a thing is, and if definitions are constructed using more universal terms, then eventually we have to reach a point where we have no more universal terms. And so we have to declare some terms primitive. And those primitive terms will be the formal ontology terms. And Aristotle had a go at working out which were the primitive terms at the very top. But now we have BFO, which is basic formal ontology, which is Aristotelian in spirit, but slightly better in certain ways. One of which is that it is now an international standards organization and international electrotechnical commission standard, which you can buy for 92 francs, or if you press on the blue button here, you can get it free. And that's for reasons which I can explain. All right, now, so how do we build domain ontologies? We know enough now how to build formal ontologies. How do we build domain ontologies? The starting point here, I believe, should be synthetic a priori truths. That's not going to be the end of a domain ontology, but it will be a good starting point in many cases. And Kant got something right. He thought that there were synthetic a priori truths, but he had a very narrow view of where we can find synthetic a priori truths. And a much wider view was presented by the Munich School, who Kevin has been talking about already today. And the two most important figures in the Munich School are going to be Scheler, who is on the left, and then Reinach, who is on the left in the bigger picture. And actually, it's more than just the Munich School. It's the Munich, Göttingen, Krakow School, which we call the Two Saints School, because there are two people who have been beatified in this small group of philosophers, which is kind of amazing. And now, and Scheler was the principal reason for this. I mean, why there are two of them.
Cause.
What?
The principal cause.
Cause. All right. Now, so what these people did was extend Husserl's formal ontology, as expressed in the logical investigations, to capture the synthetic a priori truths in various material domains. And they're described here. It's not an exhaustive list by any means, but it captures, roughly speaking, where the principal contributions of these people were. And since BFO got off the ground, we now have something like 400 of these domain ontologies, which have been formalized, and I think formalized quite well in some cases, but they're all still works in progress. And these are even more works in progress. Here we don't really have anything like an ontology. We just have intentions to build ontologies. And particularly ontology of law is an area where I'm trying to get people together who will do the work. And then Jobst and I are working on a mathematics and a physics ontology. Now, the original idea was that this would be another domain ontology like the emotion ontology and so forth. But we came to the conclusion quite quickly that neither of them can be viewed as children of BFO. That mathematics doesn't have instances, and everything in BFO should have instances. All the universals in BFO should have instances. And physics has instances, but they're often very weird, and they don't fit into BFO. And BFO, from this perspective, is beginning to look more and more like a common sense ontology, as contrasted particularly with a quantum physics ontology, which is outside the realm of common sense. And if we've got time, I'll come back to that later on. All right, now Husserl hated all of this, and he dismissed it as picture book phenomenology. So he wanted, by this stage in his career, which I guess is about 1910, philosophy to be much deeper than this cataloguing of reality, which the Munich phenomenologists were in part doing. I like picture book phenomenology. I like pictures. I think that we should mainly do our philosophy work by using diagrams. And so I don't have any problem with this. And the idea is that the synthetic a priori truths, which form part of the domain ontologies, should be representing what we call Wesenszusammenhänge. And when I say we, I mean Jobst and I. We would like to have an English word for Wesenszusammenhänge.
Essential connection. Essential connection. The problem is Barry doesn't like the word essence anymore.
So, I like the word essence, but our potential readership of boring Anglo-Saxophone analytic philosophers would react with some sort of horror if we use the word. So Kevin has been infiltrated or infected by continental modes of thinking. But we can't call them essential connections because we need both the connections and the connected structure which these connections form. So that's why I still prefer the English phrase, essential structures. And we've already seen with Jobst's account of the debt earlier, what Reinach means by an essential connection, an essential structure. So here, the connections are relations of one-sided dependence. Every promise is one-sided dependent on both a promisor and a promisee. And there is three-sided mutual dependence between the act of speaking, the act of registering, and the content of the promise. And there is two-sided mutual dependence connecting the obligation which comes into being in virtue of the promise and the mutually correlated claim which comes into being in virtue of the promise, where the obligation is on the side of the promisor and the claim is on the side of the promisee. And then there is the tendency towards the realization of the promise, which is an action to do F, where F is the content of the promise. One further element, which I think will form part of the ontology of law, and which I've tried very hard to make fit neatly into the BFO framework, is the following. I believe that in any society in which there is promising, there has to be a social institution of occasionally punishing those who do not realize their promises. If you don't have that the institution of punishing, and the punishing may be as small as just lifting an eyebrow, or it may be just chattering about people behind their back, or it may be putting people in jail, but there has to be some form of punishment, otherwise there can be no institution of promising in society. Reinach doesn't address that question. I've tried to make it work in BFO, and it's very hard, but we will keep working. All right. Now, what is the mode of being of a Wesenszusammenhang? So this is a picture of something general. It has instances. The instances of this structure are Wesenszusammenhänge too. So we have Wesenszusammenhänge as general structures, and we have Wesenszusammenhänge as instantiations of those general structures. When somebody actually makes a promise and does or does not realize it. So Reinach is a Platonist. That may have been the correct position, may still be the correct position about question 1, but he's obviously not a Platonist about the instances of Wesenszusammenhänge. So he's perfectly familiar with the fact that when we make a promise, there is a social act, which is an instance, it's a performance, which takes place at a certain time and in a certain place. So we need to deal with both of these too. Whether we have a Platonic answer to the first question is not important for this purpose, but what I am interested in is the way we treat number 2. That is to say, the instances. Now, another thing that Reinach is very keen on is that there can be modifications of social acts, and this is going to be important later. So we have Wesenszusammenhänge. Practically every component of this diagram can be modified. So there may be no promisee, because the promisee dies before the promise is completed. There may be no speaking. It may be that there's just a waving of the hand, which counts as a bid in an auction or something, and a commitment to pay. And it may be that the tendency towards realization is never brought about, again, because the promiser was not, the putative promiser was not sincere, and so on. So there are all kinds of ways in which this structure can be modified. But Reinach thinks that this is the basis for understanding the relationship between what we can think of in his terms as Platonic law, which he sometimes called natural law, on the one hand, and positive law on the other hand. That is to say, we have Wesenszusammenhänge, which connect legal formations and which we can recognize with insight as holding of those legal formations. But then there are various ways in which we can modify these Wesenszusammenhänge, some of which are still a priori, some of which belong to the positive law. Belong to the positive law in a way which is still eidetically recognizable as possible, says Reinach. All right, so these are examples of eidetic modifications which are within the realm of the a priori, but then these are examples which belong rather to the positive law. And he mentioned specifically the case of a positive law might say that contracts of certain sorts are not valid if signed by a minor, for instance, or that certain contracts have special legal status if they are co-signed by a notary, or certain contracts may be set aside because they satisfy all of the conditions of specific paragraphs of the Bürgerliches Gesetzbuch, or contracts signed while drunk may not be counted as satisfying certain conditions, and so forth. And there are more here then. So ChatGPT made a promise. It seems that ChatGPT did make a promise to some girl, and the promise had to do with love. And ChatGPT then shunned her.
It promised you the Turing test, you remember?
It tried, but the girl committed suicide. And so we should really be worried about AI because it's dangerous, people say. And so on. So these are other sorts of modifications which are, to some degree anyway, outside even the realm of the positive law. All right, now there's something very similar going on in Karl Menger. Now, Karl Menger was the founder of the Austrian School of Economics. He himself was not influenced by Brentano, who was the grandfather of the phenomenologists, but some of his followers were closely influenced by Brentano and by Brentanians. So Friedrich von Wieser, who Kevin talked about, lived in Prague. I think he lived on the same street as Anton Marti, and I think that they were related by marriage somehow. So there is a story to be told about the connections between the phenomenologists on the one hand and and the Austrian economists on the other hand. And I talk about some of this in the book on Austrian philosophy that I published. But Menger himself, it seems, was just a typical Austrian schoolboy, which meant that he didn't read Kant in school. He read good philosophy like Aristotle and Bolzano, or Bolzano paraphrased.
Like Szymanski.
And the
Szymanski was Bolzano's student who published textbooks.
Oh, I know.
In Austria.
Das Neue Anti-Kant.
Oh, God.
All right. So what is economics according to Carl Menger? Well, it's the study of the necessary dependence relations among the various constituent parts of the economic domain. And these dependence relations are intelligible, and an exchange, for instance, an example of such a dependence relation would be that an exchange depends upon an exchanger and an exchangee, and the later followers of Menger, particularly Ludwig von Mises and the followers of Ludwig von Mises, took this a priori approach to economics even further than did Menger. So this is an example of Wesenzusammenhang in the economic domain.
But he didn't call it himself Wesenzusammenhang, right?
No,
yeah.
no. So this is about a good. In order for a good to exist, you need a need. You need a causal connection between the entity in question and the satisfaction of this need. You need knowledge of this causal connection, and you need command over the thing, which would be ownership, which is sufficient to enable the thing to be directed towards the satisfaction of the need. And I think that there is a lot of an account of essential connections in Menger along these lines. It's not all of his economics by any means, but this is the basis. And I should mention that there is another man called Carl Menger, Carl with a K, who was the son of Carl with a C. And Carl Menger was part of the logical positivist circle, and so he was keen to not have his father have been a follower of Aristotle. And so there are claims made by Carl with a K that all of these kinds of expressions are not to be understood as implying any kind of essentialism or ontological thinking, that in some way to be interpreted positivistically, but I don't buy that. So these are examples of some of the categories that the economist is interested in: buying, selling, ordering, contracting, and so on. And I think everyone in this room is familiar with how we deal with those kinds of phenomena in the ontology of economics. Now, so we have domain ontologies. I've talked a little bit about a legal domain ontology and about an economic domain ontology. The idea is that we can develop domain ontologies like this by doing two things. First of all, we search for the intelligible structures which are part of that domain. And then once we've done that, we move on to look at the empirically existing subcategories, which may no longer be subject to being structured in any intelligible way, but which may just be the random developments of engineering or whatever it might be. And we can do this in surprisingly many domains, and it's useful to do it in surprisingly many different ways. But now I want to come to what I think is Reinach's most important contribution. And I think I'm safe in saying that it was Reinach who was the first to do this. So in the history of philosophy, there have been many philosophers who think that there is only one sort of history. And by history, I mean the way a thing develops over time. According to Plato, the things which exist never change. Everything else is just appearance. And so this is the one sort of history. It's a flat, boring nothing. And then the other group, which is nearly everybody else, says that there is only one sort of history in reality, which is the history of changing all the time, as the planets and the people and the weather and so on are changing all the time. And then there are the really exciting philosophers who say that there are two sorts of history. There are the unchanging histories of mathematical entities and other kinds of abstract entities. And then there are the causal changes that happen to non-abstract entities like people and planets and so on. So we have two kinds of histories. And now this is Reinach's principal contribution, that in addition to ideal entities and material entities, there are entities which have features of ideal entities, but which are rooted in history. They have a beginning. And this idea was taken up by Ingarden. From Ingarden, it was taken up by Amy Thomason. Searle got close to it at various points, but then he gave the game away by saying, but of course, those things are not real. And so Reinach, I believe, was the first person to accept an ontology of abstract historical entities. And examples are debts. So a debt is an abstract entity. It has some mathematical features. It can be divided into 100 exact parts when you issue bonds, which is a mathematical phenomenon, which doesn't relate to the world of people and tables and trees and so on in any direct way. But a debt is not like a number or a concept or a proposition, because it has a beginning and an end to its existence. And then we can think about what other kinds of entities belong in this third category, and many kinds of social entities, laws, claims, property rights, knighthoods, many things belong in this realm. Ingarden would say that works of art belong in this realm, including sculptures, because while not including sculptures, sculptures are like other works of art in the sense that they are dependent upon subjects, but unlike some other works of art, they have molecules inside them. All right, and the state, of course, is an example of an entity which has a history, but which is such that it doesn't change. That's a little bit hard to claim, but I think I can defend that. All right, and then literary works and musical works are Ingarden's favorite examples. And money, prices, stock, contracts, all of those things are all entities which do not change, but which belong to the world, to the historical world.
Can you go back to Stein once more? Sorry.
Stein?
Okay, yeah, thank you.
All right, now let me say a couple of things about the ontology of mathematics that we're developing. So we have mathematical entities, we have constructors such as plus and minus and set of. We have monads, maybe not exactly these, but zero certainly is a good candidate to be a monad. A monad means smaller than a structure. In other words, it's the smallest building block for creating mathematical entities. And then the most important mathematical entities are Wesenszusammenhänge of a mathematical sort. So what we're going to do, Jobst is not completely convinced about this yet, is to create a counterpart of Reinach's ontology of law, but we're going to do a counterpart in the realm of mathematics. So it's easy to see how we can create a Reinachian counterpart of the ontology of economics, I think, from what I've already said. It may be hard to see how we can do it in the realm of mathematics, but we will see. So these are we haven't got very far in the mathematics ontology. We are really very, very much at the beginning, but there are three kinds of essential structures. First of all, there are functions, then there are operators, and then there are fields. And these are three examples. So a function takes you from a vector of n real numbers, for instance, into one real number. It's a mapping from n to 1. An operator is a mapping from n to k, so it doesn't take us to 1, it takes us to another vector. And then a field is something like the field of real numbers, or the field of integers, or field of complex numbers, and so on. So these are all very simple distinctions. And now, what is common to both fields and operators is that they can be viewed as two-place relations. And what that means is that they are subsets of the cross products of the totality of vectors Rn and the totality of vectors Rk here. And so this is a two-place relation. It's applied by ChatGPT, just like that. I told it to give me a two-column database which represented some real physical connection. And so it came up with this. And on the left, you have temperature. On the right, you have linear expansion. I didn't even check what.
Wow.
All I needed was a...
Should be Kelvin.
No, I told it to give it to me in degrees Celsius. So this is what it gave me. I don't think it's doing any harm. You can get it to do things like that. And we had a candidate for a job in Buffalo, and we were all asking questions. And so I got ChatGPT to formulate a question for me, which may have been the first time in history that ChatGPT was used to ask a question in a job interview. All right. Now, so these are the mathematical Wesenszusammenhänge, or a first very, very rough outline of possible mathematical Wesenszusammenhänge. Now, what are going to be the modifications which correspond to the modifications in positive law of legal formations described by Reinach? Well, first of all, we have applied mathematics, and applied mathematics is to some extent restricted from the absolutely general realm of the Wesenszusammenhänge to the more specific realm represented by physical magnitudes. And an example here might be a finite Hilbert space used in quantum mechanics. It's not a mathematical Wesenszusammenhang, or rather, it is a mathematical Wesenszusammenhang, but it's of a very specific sort. In something like the way in which a smoking philosopher is a specific sort of human being. And but then, more interestingly, and this is the only place where I really use ChatGPT in this talk, there is a distinction which has become important because of AI between explicit mathematics and implicit mathematics. Explicit mathematics is the more familiar kind of mathematics where a mathematician has a thought, writes down some axioms, tries to prove some theorems, modifies the axioms, and so on, and everything is done explicitly on the paper in front of her.
Should be Legendre.
I see. Good. No, it's me who should be saying I'm sorry. Legendre.
Lagrange was a big Legendre. Was a big
like that?
Legendre.
Legendre. Good.
Lagrange was an yes.
Instead of it.
Yes.
3 E's.
Yes, 3 E's.
Yeah.
Thank you.
The
other one was a bigger genius, but still, we should not. Legendre also did something useful.
Yeah, I will tell ChatGPT. All right, so there is explicit mathematics. But then there is implicit mathematics. Now, ChatGPT is really just a gigantic algorithm. It's an operator, a function. You give it input and it gives you some output, which may be more or less funny. How is it built? It's not built by having some people in Google or Amazon sit and write out this function. The function maybe has 100 billion parameters. It's going to be a very long function. How is the function built? Well, it's built by giving training data to the computer. You train the algorithm so that it will recognize or generate patterns for conformant to certain rules by giving it sample data about such patterns. And the sample data is used to train the algorithm so that it recognizes more such patterns. And in the case of ChatGPT, creates more such patterns in a very interesting way. So these are pieces of mathematics. They are algorithms. They're just like any other function. It's just that they're very, very long. And they're by no means essential structures. They're not Wesenszusammenhänge because they have 100 billion parameters. And no human being can ever understand an algorithm with 100 billion parameters. We can use them, but we can't understand them. So there are two sorts of mathematical entities, just as there are two sorts of Wesenszusammenhänge and modified Wesenszusammenhänge along the lines that I described. So the Wesenszusammenhänge in mathematics are fields, functions, and so forth of the sort which we read about in mathematics textbooks. And the modified structures in mathematics are, for instance, ChatGPT. And now, one of the issues that Jobst and I have been arguing about with Kant always serenely.
No.
With,
not with Kant.
Not with Kant. I was going to say with Kant serenely in the background, looking over Jobst's shoulder. So are the general Wesenszusammenhänge discovered, which Reinach would say, because he's a Platonist, and I'm sure he's a Platonist about mathematical structures, or are they created with the development of the brains of the members of the mathematical community, roughly speaking? So pi looks as if it was created at a certain point in history. And should we accept a view of the Wesenszusammenhänge in which pi is involved as being created in history with the gradual historical development of mathematical knowledge? I am neutral about that question. What is important is that even if they are created in time, they are still accepted by the mathematicians as being abstract entities which have some sort of atemporal validity. So pi is a universal constant for all time. That's the way mathematicians understand it. That would be so even if pi was created at a certain point in Greek history. And now that is we have a big difference then when it comes to the second kind of mathematical
That's
entity.
not a mathematical entity.
Which?
ChatGPT.
It is according to this picture.
Yeah, that's now you contradict your own paper there.
Because?
Because we said, well, that's not.
No. Anyway, we'll have a discussion in a minute. So, ChatGPT, considered as an algorithm with 100 billion parameters, or however many parameters it has, is a mathematical entity. That's what I'm claiming. But it certainly begins to exist. There's no question of a Platonic theory of ChatGPT. It exists as a historical entity, like a debt, or the new digital money that we're going to have. And one feature which shows that it's a historical entity is that it has versions. So there are now several versions of ChatGPT. There's the legacy version, there's the 3.5 version, there's the 4.0 version, and so forth. Mathematical entities themselves, the Wesenszusammenhänge of mathematics, do not have versions. And I think that could be the end.